In this video, we're going to be working with simplifying radicals. And to start off with, I'm just going to clarify what exactly a radical is. This symbol right here is, although you may be more familiar with the term the square root symbol, the technical term is radical. Now, I'm going to write a couple expressions here. So, the square root of 25, the square root of 16, and the square root of 49. Now, what do all of these expressions have in common? Well, each one of them has a whole number answer. And the reason this is each of these numbers under the radicals are what we call perfect squares, which means that their square root is a nice whole number. So, what if you're given a problem where the number under the radical is not a perfect square, such as the square root of 18? Well, we know that the square root of this is not going to be a nice whole number as up here. However, we can simplify this expression just a little bit. So that's what I'm going to show you how to do here. So square root of 18 can actually be rewritten as the square root of 9 times 2. And this is the same as the square root of 9 times the square root of 2. And the square root of 9 equals 3, so we end up with 3 times the square root of 2. Now you may be asking yourself, how did he know to use 9 and 2? Why didn't he use 6 and 3? Those both multiply to get 18. Well, this is where a little bit of memorization comes into play here. And to simplify radicals, it's going to be really helpful if you are familiar with what we call the perfect squares, which are 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on, because 2 times 2 gives 4, 3 times 3 gives 9, and 4 times 4 gives 16, and so on. So these are the perfect squares up to 100. Now, when you are simplifying radicals, it's really important that you know these. So I'll give you another example of the square root of 27. Now, this is not a perfect square. It won't have a whole number answer, but we can simplify it. And how we would go about doing that is we look over here at our perfect squares and we try to find something on this list that will divide evenly into this number. And ideally we want to find the biggest number that will go into it, but it wouldn't be critical if we didn't. So we have the square root of 27. It's not divisible by 4. However, it is divisible by 9. So we're going to rewrite this as the square root of 9 times 3, because 9 times 3 gives 27. And as I did above, we can break this up into two separate radicals of the square root of 9 times the square root of 3. So, and now we know the square root of 9 gives 3, so we end up with 3 times the square root of 3. So that's how you do these. So let's give you another example of the square root of 60. Now again, we're going to look over here at our list of perfect squares, and we're going to try to find something that goes into 60, essentially the biggest one, preferably. So 60 would be about here. 49 isn't going to go into it. 36 does not. 25 doesn't. 16 won't. 9 doesn't go into 60. However, 4 does. So 4 is actually the biggest perfect square that goes into 60. So we're going to rewrite this as the square root of 4 times 15, because 4 times 15 gives 60. And again, that's the square root of 4 times the square root of 15. And the square root of 4 is equal to 2, so it's going to be 2 square root 15. Okay, so now let's put a number outside the radical. So we have 4 square root 75. So 4 times the square root of 75. Now, it's not going to be any different here. 75 is not a perfect square, but we can simplify it. So 75 is about here. 64 won't go into it. 49 won't. 36 doesn't. But 25 goes pretty nicely into 75. So we're going to rewrite this as 4 times the square root of 25 times the square root of 3, because 3 times 25 gives 75. Now, let's simplify it now into 4, and the square root of 25 is 5, so times 5 times the square root of 3. And 4 times 5 gives 20, so it's going to be 20 square root 3 as our answer. Okay, so now let's assume that we had a relatively large number, something like 810, and we got to simplify that down. Now you may not know just off the top of your head the biggest perfect square that will go into 810. I certainly don't. So what you can do, this is why I mentioned it's not crucial that you get the biggest perfect square that goes into it, because you can do it in multiple steps. So let's look over here at what might go into this. It looks to me like 9 is going to go into 810 because of this 81. 9 goes into 81. So let's try that one out. So equals the square root of 9 times, and it's okay to use a calculator on these because sometimes you just have to. And 9 is going to go into 810 90 times. So 90. Okay. So we can break this up. Square root of 9 times the square root of 90, which gives us 3 times the square root of 90. Now, at this point you have to ask yourself, are you done? Because this number here can still be broken down further, because we didn't use the biggest perfect square that goes into 810. So we got to start over again with 90 now. So what's the biggest perfect square, or even not necessarily the biggest, just any perfect square that goes into 90? Well, 9 looks like it's going to go into 90 again. So this is going to be 3 times the square root of 9 times the square root of 10, because 9 times 10 gives 90. So now we just simplify further. 3 times 3, which is the square root of 9, times the square root of 10. 3 times 3 gives 9, and we have our square root 10. Now again, ask yourself, are you done? Well, can we break down the square root of 10 any further? Well, 9's not going to go into it, and 4 doesn't either. So this is the simplified form of the square root of 810. So that's how you simplify radicals.